We have binary tree zigzag level order traversal. We have been given the root of a binary tree and we have to return the zigzag level order traversal of its nodes. That is level order traversal. It means we will have to do a BFS and it's a zigzag from left to right, then right to left for the next level and alternate between. Okay, so first we go from left to right, that is 3. The only node is 3, so we know we have to do BFS, that is level order. Then first we go left to right, then right to left, then left to right. So we take 3, that's the only node in the first level. Then we have 9 and 20, but since we have to do right to left, so we do 20 and then we do 9. Okay, and then in the next level we have null, 15 and 7. So we get 7, 15 and null is ignored. So this should be our answer. This should be our answer and it should match. Let's see, 3, 29, 15, 7. 15, 7. Oh yeah, right, we have to do left to right. I did right to left, we have to do left to right, so it would be 15 and 7. Okay, so we know that we will have to alternate, so we will have to keep some sort of flag that lets us know that it's going to be left to right. And let's write BFS. We will have to maintain a queue, and let's check the constraints first. It can have 0 nodes, so that's gonna be if root is null, then we simply return root. Otherwise we add root to our queue, and while queue has some nodes, we will also have to maintain a result set. Let result, it's going to be an array, and while we have queue, we can also maintain the level, so it will be root and level is 0. Let level 0, or we can just simply keep it here, and then let level node, so this is going to be q dot unshift dot shift. It's going to be node, so now we have node. Let's have level order nodes equals to empty, and then we have order let is left to right. It will be true initially, since we know that first it's going to be left to right, and then we push our nodes node to this, and then if we have a node dot left child, we push it to our queue dot push node dot left. If we have a right child, we push right. So now we have in the queue we have this. Okay, and we can remove this and remove this, and then store at level if we already have this, and dot length we already have this. Then what we do is we simply push our node, else equals to undefined. If it's undefined, then what we do is we make it an empty array, and then push our node to it. In the end we will have all of our nodes in the array, and then what we do is we iterate over this result for let this level result of result let I equals to 0, I is less than result of length I plus plus, and initially let is left to right is true. So if it's if right to left is initially false, if it's false then we take this and we inverse it, and then we'll return our result. Let's take the example of example 1. We have let node, we have queue, so we set a root and then level queue dot push. This is going to be like this, level plus 1. Now it's not null. We set queue, then we set result. Queue is not empty. We take node and level, that is 3 and 0, and we push to level order nodes. We don't have to push it, and then we see if there is a. We can do it right here. Result level dot. We can move it to the end. If we don't have the element in the result like this, then we initialize it as an array, then we add our node to our result and then we take the left and add it to our queue, take the right, add to the queue. Then in the end, when all of it has been iterated, iterate over our result array and then reverse whatever has to be reversed. This doesn't look, it's not a valid value for the expected return time. No, it's not a valid value. Okay, this is this. We have to push node to the val. Okay, looks good. We can maybe reduce this for loop and do all this here using a flag. For now, let's try to submit it.